The electrical systems used on Evinrude and Johnson outboards. Topics include charging system and starter system theory and servicing procedures. First, we'll examine the charging system. Its job is to keep the battery charged so the battery can start the outboard. Depending on the engine model, Evinrude and Johnson outboard charging systems can provide from 4 amps to 40 amps of charging current. There are two types of charging systems used on Johnson and Evinrude outboards: non-regulated and regulated. Let's begin by examining a non-regulated charging system. This system consists of a flywheel, an alternator stator, and a rectifier. Let's take a close look at how these three components work together to generate electricity and charge a battery. Moving a magnet back and forth through a coil of wire creates or induces voltage and current flow in the wire. This is called alternating current, or AC, because the current flow changes direction every time the magnet changes direction. A non-regulated charging system uses flywheel magnets and an alternator stator to produce AC in much the same way. The stator consists of a laminated steel core with wire windings. It's located under the flywheel, close to the magnets in the outer rim of the flywheel. As the flywheel rotates, its magnets move past the stator. When the poles of the magnets align with the bosses on the stator, a magnetic field flows through the stator's metal core, inducing current flow in the wires wrapped around it. As the magnetic poles move past the stator bosses, the magnetic field induced in the bosses constantly changes. This constantly changing magnetic field produces AC electricity in the wire wrapped around the stator. However, the outboard's battery, electrical system, and accessories require current that flows in only one direction. This is called direct current, or DC. So the AC output from the stator has to be changed, or rectified, into DC. A rectifier circuit containing diodes is used to change AC into DC. You can think of a diode as a one-way valve for electricity. Current will only flow through a diode when its anode end is more positive than its cathode end. The cathode end of a diode is identified by a stripe. A circuit with two diodes, arranged like this, allows current to flow from the stator to the battery only when the yellow wire is negative and the yellow-gray wire is positive. When the yellow wire is positive and the yellow-gray wire is negative, the two diodes block current flow from the stator to the battery. This circuit is called a half-wave rectifier. A circuit with 4 diodes, arranged like this, allows current to flow from the stator to the battery if either wire is positive or negative. This circuit is called a full-wave rectifier. Notice that when either stator wire is positive, it is connected to the battery's positive terminal, and when either stator wire is negative, it is connected to the battery's negative terminal. When the stator's leads switch polarity, the rectifier's diodes automatically redirect the current flow to the battery. This is how a flywheel, stator, and rectifier work together to generate electricity and charge the battery. Now let's examine the wiring diagram of a typical non-regulated charging system used on small outboards. Yellow and yellow-gray output leads from the stator supply AC through a terminal strip to the rectifier. A red output lead from the rectifier supplies DC to the battery through a common battery terminal on the starter solenoid. A gray lead from the terminal strip directs AC from the stator to the tachometer. Tachometers on most outboards are driven by the charging system, not the ignition system. Before we move on, you must be able to differentiate a non-regulated from a regulated charging system. A good way to identify a non-regulated system is the rectifier. All recent outboard models with this style rectifier have a non-regulated charging system. Some 1983 and older V4 and V6 models may have an accessory regulator in addition to a rectifier. When testing a non-regulated charging system, you should always test the charging output before checking other system components. To test the output, you must be able to run the engine in a test tank or on a marine dynamometer up to approximately 4,500 RPM. To perform the running output test, disconnect the rectifier's red output lead from the terminal strip. Connect an ammeter between the red lead and the terminal strip. Run the engine and measure the current output. Compare it with the specifications in the service manual. If the current output readings are within the specifications, the stator and rectifier are functioning properly. Continue testing the charging system by checking for loose electrical connections. Loose connections can cause damage to the charging system and other electrical components. Next, test the battery as described in the manufacturer's instructions for the battery or test equipment. The stator must be tested if the charging system's output does not meet specifications. First, disconnect the yellow and yellow-gray stator leads from the terminal strip. Connect the leads to an ohm meter. Measure the resistance of the windings as described in the service manual. If the stator is within specifications, test the rectifier. Use a multimeter to test the rectifier diodes, following the procedures in the service manual. To accurately test diodes, most multimeters require a specific scale or switch position. Refer to the meter's manual for information on how to test diodes with your multimeter. Remember, always use the correct service manual when testing and servicing a charging system. Now let's look at how a regulated charging system works. A regulated charging system, like this 35 amp system used on some larger outboards, is similar to a non-regulated system. The major difference is that it has a rectifier regulator to protect the battery from excessive charging current. Like a non-regulated system, DC flows from the rectifier to the battery. But when the battery reaches full charge, the rectifier regulator senses it through the red lead, and the regulator directs the charging current to ground. The regulator will allow charging current to flow again when it senses a low charge on the battery. The rectifier regulator is often located at the top of the engine block. It is set in a water passage to keep it cool. Some smaller outboards have an air-cooled rectifier regulator. On late model Evinrudes with direct injection, the rectifier regulator is incorporated into the Engine Management Module, or EMM. Some rectifier regulators are powered by a purple lead. This lead is powered only when the key switch is on. Other rectifier regulators do not have a purple lead and are powered directly by the stator. Like the non-regulated system, the first test you perform on a regulated charging system is the running output test. However, you must provide a load to the system before testing its output. Unlike a non-regulated charging system, a rectifier regulator does not have a continuous output. Depending upon the charge condition of the battery, output current may or may not be flowing from the rectifier regulator to the battery when you test the system. You could mistakenly assume the charging system is not working. Remember, there is no charging current output from a regulated charging system until the rectifier regulator senses low battery voltage. There are two methods for checking the current output of a regulated charging system: the cranking discharge method and the variable load method. First, we'll look at the cranking discharge method. Connect a voltmeter to the outboard's battery and measure its voltage. If the battery voltage is 12.5 volts or higher, some energy must be drained from the battery before the charging system can be tested. Disable the engine's ignition system and crank the engine in short bursts until the battery voltage is less than 12.5 volts with the key in the off position. Disconnect the red output lead between the rectifier regulator and the starter solenoid. Connect an ammeter in series with the red lead and the battery side of the solenoid. Run the engine at 4,500 RPM. The ammeter should indicate nearly maximum output from the charging system. As you continue running the engine at 4,500 RPM, the battery voltage should stabilize around 14.5 volts, and the charging system's output should begin to decrease. If the engine passes this test, the flywheel, stator, and rectifier regulator are functioning properly. Check the battery next. Do not use wing nuts for battery cable connections. Hex nuts and star washers are required to securely fasten the battery cables to the battery posts. For direct injection models, the clamps supplied with the outboard must be used. Check the charging system for loose electrical connections. Loose connections can damage the charging system and other electrical components. The second method for checking the current output of a regulated charging system is the variable load method. This method uses a variable load tester to load the battery and make the charging system function. Disconnect the red output lead between the rectifier regulator and the starter solenoid. Connect an ammeter in series with the red lead and the battery side of the solenoid. Connect a variable load tester or carbon pile resistor across the battery terminals. If the tester does not have a built-in voltmeter, connect a voltmeter across the battery terminals. Start the engine. Run it at 4,500 RPM. Use the variable load tester to draw the battery down at a rate equivalent to the charging system's rated output. The ammeter attached to the outboard should indicate the charging system's output. Decrease the load on the battery. The ammeter should show reduced charging output. The charging system's output should approach 0 amps as the battery voltage stabilizes around 14.5 volts. If the engine passes the running output test, the flywheel, stator, and rectifier regulator are functioning properly. Check the battery and wiring connections if a problem persists. If the regulated charging system does not pass the running output test, the stator must be tested. Disconnect the stator leads. Check the stator following the service manual. If the stator's resistance is not within specifications, replace it. There are no tests to check the rectifier regulator by itself. By testing the charging system's output and the stator's resistance, you can, by process of elimination, conclude a problem is caused by the rectifier regulator. Another feature of the regulated charging system is the tachometer circuit. The AC voltage signal to the tachometer is measured with a peak reading voltmeter or multimeter that reads frequency in hertz. The primary components of an electric start system are the battery, the key switch, the starter solenoid, the starter motor, and the neutral safety switch. The engine starts when the starter motor's teeth engage the flywheel and crank the engine over. The starter needs high amperage to operate, so the starting system uses a relay called a solenoid to deliver high amperage to the starter motor. Let's see how a solenoid works. Current applied to the small posts on the solenoid flows through a wire coil to ground. This produces a magnetic field, which attracts the plunger and draws it up inside the coil. A metal disc attached to the bottom of the plunger connects the two large posts of the solenoid. Here is how a typical start circuit works. Current travels from the battery to the key switch through a fused circuit. When the key is turned to the cranking position and the control is in the neutral position, current flows through the yellow-red lead to the small terminal on the starter solenoid. When the solenoid actuates, the disc electrically connects the two large posts, allowing current to flow through the solenoid to the starter motor. Bombardier recommends different batteries depending on the engine size. The battery specifications for each model are printed in the correct service manual and in the operator's guide. When troubleshooting an electrical system or installing a battery, make sure you verify that the battery meets or exceeds the specifications. Some boats require more than one battery. For example, a boat that has an electric trolling motor or many electrical accessories may need two batteries, one to start the outboard and the other to operate the accessories. Two devices allow the engine to charge more than one battery at a time: a battery switch and a battery isolator. The battery switch is used to connect the charging system to the main battery or to both the main battery and secondary battery. Tell your customers never to turn the battery switch off while the engine is running, or the charging system can be severely damaged. Always stop the engine first. The second device used with multi-battery systems is a battery isolator. Some models have a built-in battery isolator that eliminates the need for an aftermarket accessory. It is important to understand charging and starter system theory and testing procedures. This will help you to quickly and efficiently diagnose and repair electrical systems.